So, video part two. We're just winging it here. I'm not sure if I'll even be able to upload this. If you're hearing this, it worked the first time. I guess if you're not hearing this, you wouldn't know, because I would have fixed it. But whatever. So, understanding secondary data. Alright, so I am extremely, I don't want to say proficient, that's not the right word, familiar with secondary data and how to do it and how to look at it. It's basically all I do until I can get a grant funded and start collecting my own data again. So, the first part is to always familiarize yourself with the original study data. Use the technical manuals, the user manuals, read them. Sometimes they're hundreds of pages long, but it's critical to know where your data comes from. It's important to know who the results are generalizable to. So I'm going to pull up this example from NHLBI. It involves people undergoing lung resection surgery related to emphysema from like 1998 to 2004. It can be used to make inferences about people that underwent the surgery in 98 to 99, because that's when the surgeries were completed, because the follow-up took place from after surgery all the way through 2004. We cannot use these data to make inferences about the people undergoing the same procedure today. Can we make inferences about other variables in the follow-up period? Maybe. Can we use it as supporting data? Yes. But can we make surgery outcome inferences based off something that happened 20, 21 years ago? We cannot. So it's important to know this information. Can we make valid conclusions that are applicable to today's people? It's extremely important to know how missing data are handled, because you will find way more missing data than you're probably anticipating, which you will see later. What are the appropriate analysis weights? So sometimes you need to know if how it's coded. Is something weighted heavily? Is there conversions? Are there scoring mechanisms? All important. What is the appropriate method for computing adjusted standard errors? So this is a little bit more technical, but just can throw off your analysis if you're not sure how your errors are computed in the program, if at all, or if they give you just raw data, which is very nice. You don't have to worry about it. What are the composite variables and how are they constructed, aka instruments? So if they are measuring depression, do they give you all 9 questions of the PHQ-9, or do they just give you the PHQ-9 total score? These are, it depends on your research question, obviously, and if you're even going to be looking at those variables, but very important to know. So here's, we're going to kind of just work through understanding secondary data. First and foremost is familiarizing yourself with the original study and data. Examine the questionnaires, the interview protocol. Holy cow. Just keeps popping up. The interview protocols, if they're available. Identify if there's any skip patterns, if there's any rhyme or reason to missing data. So here's an example, and I'm going to upload this to Canvas. By the time you're listening to this, I'm going to upload this data set for you guys to kind of poke around with. It's huge, and we're going to go through an example. But here, I have isolated 2 variables, blood infection source from the donor. So this is from a big data set of transplant recipients. These are all the thoracic recipients, so people receiving heart, lungs, mostly. Heart and lung or heart. And there's ways to find out, but it's important to know how the organs you're getting for transplant, were they septic and did they die? So here you can see it's pretty much the same thing. Here, same variable, blood infection from the donor. We have zeros here, and we have blanks and Y's. What the heck does that mean? So you have to go investigate what that means. So let's see, I'm gonna pull it up here. So this is where I got the data from. We're gonna go here. I think it's under important documents. Star file documentation. So this is the code book that they gave me. It's only part of the code book. So here I'm gonna, you have to, and of course I'm whizzing through this, right? Because I've looked at this quite a few times. But here, you know, so I'm in the thoracic data. So here's intestine, pancreas, liver, thoracic, okay. And I know I'm in the thoracic data set. I'll click that, and then what am I trying to find here? I'm trying to find blood infection. Okay, so that's the variable name. Let's see if we can find it here. Blood infection. Okay, deceased donor infection source confirmed via culture. Okay, it's from whatever that form is. It's saying this is the form. So I'm sure somewhere in this big old this is all I have. Code dictionary. It might be in here. I have to find. If I was interested, I could find DDR, right? Maybe it's in here. Data collection forms. Okay. I don't know what DDR is, but we'll call it. We'll see if it's TCR. We have to go to. Well, here's heart, lung, liver. It's combined. I don't know. So it might be under there, you know. So this is part of the secondary data. You have to find out. But anyway, back to our problem here. So here, it gives us these, but it doesn't give us what they mean. So we go over its clinical information. It tells us everything we already know. There's no comments on it, so what the heck does it mean? So I happen to know that this lookup value here tells us a lot. So these are what are called flat files. They'll tell us a whole lot. So we go to the flat file, and then all of a sudden, this is data field formatted value and SAS analysis format. It actually does not tell us the name anymore. We have no clue what this means. So here, this is biopsy, this is blood, this is something like that. So what does it mean? We're past our B's for blood infection, right? So where do we find this? Look at all these different cancer combinations. These are all coded cancer combinations that people can have. Can you imagine that? Like we're at 6, 7, 8, 9, 10, 12, 15, over 15, 16,000 different cancer combinations people in this data set have that are individually coded. So let's see here, status. So, it's not in our data lookup values that we can see from our eyeballs. So maybe we do a control find. Infection. Let's craft infection. Infection. Here we go. Alright. That's not what we need though. Those are all the different types of infections you can have. Alright, and it's not here either. So, you guys get the point. This is an exercise of showing the point. I happen to know that it's in one of these PDFs. It's not this one. I happen to know it's in one of the PDFs that will tell you at one point in time this data sorry, got distracted. At one point in time, the data were collected as just yes or no, pre 2015. Yeah. So pre-2015, it was the blood source confirmed from the donor confirmed as an infection? Yes or no? No was left blank. So it was yeses and blanks. So you didn't actually know if it was completed as no's or not done at one point in time. And here they switched to, they coded it here. So here you can see it's zeros and ones. So this just shows you if you were concerned about the donor's blood having an infection in it, you would have to go and figure this out. You'd have to do some investigative work. How was this collected? There's a time here. What is it coded as? You obviously do statistics on numbers, not letters. So I hope that kind of roundabout, probably 5-minute example made sense. Another example of familiarizing yourself with original study data. So you have to examine questionnaires, interview protocols, examine the main outcome in longitudinal data sets, and determine whether the same construct is being measured across time. So for example, in the same data set I just pulled up, key indicators or questions may be modified over time. So prior to 2005, there was no single indicator for lung allocation priority. So they didn't really have a set system of who got a lung when and in what priority for those on the wait list. So 2005, some scientists made a lung allocation score. So I'm trying to remember exactly what was on it. It's about 6 or 7 different things. So in this particular data set, I know, ignore this right now, just listen to my words. So pre-2005, they were looking at things like your diagnosis, your ABG values, your lung function values, and some hemodynamic indices based on the diagnosis that they had. And that was determined who got a lung when, on top of all the matching stuff. After 2005, when the lung allocation score in this data set, they stopped recording some of those indices that were important for determining clinical status. In 2005, they just recorded it as a lung allocation score. So if you go back here, let's see, composite variables are available, and how are they constructed? The LAS is a composite variable. It's made of stuff. So if I go here, allocation score, we can click on it. Oh, that's not what I wanted. This is what I wanted. So here, age, height, weight, lung diagnosis, functional status, diabetes, ventilation, O2, all of these different lung and hemodynamic indices. And that's what makes up the LAS. And that is no longer recorded after 2005, some of these things. So you have to just know what makes what. And if you're interested about any of those individual parameters, you might be out of luck. Also, we briefly touched on some of these indicators or questions might be modified over time. So look here, we're gonna pre 1999, they cared if you had cigarette use. TCR means prior to transplant, aka waiting list. They only really cared if you had 20 pack years. Then, at some time, they wanted to know if you've been using during the last 6 months for greater than 10 years of smoking history. And then here, it doesn't show it in the value here, but this is another measure of history of cigarette use. And then the most up-to-date one is that they had here in the data set, pre-2004. They went from no longer continued use, but here's pack years, and then they go to from 20 to 10 pack years. So it just shows how kind of their data collection strategies have changed over time. Let's see, I'm going to cut this off since it's going on 15 minutes.